I'm going to give an overview of the Digital Slide Archive, which is a software platform we've been developing to manage and analyze large or whole slide digital images. Over the past year, we've been working on simplifying installation, working on annotation. I'm going to talk a little bit about the user interface, and then finally talk about our analysis framework. So first, importantly, is how to install the software. So one thing I've dealt with in a lot of academic software is it's extremely difficult to install. So in this instance, essentially, we've worked on getting it down to a couple of steps. In this case, I'm demonstrating Vagrant, which is one of many different ways the software can be installed. And what you're seeing here is it actually running on my laptop. Now, what most people are actually going to prefer is a Docker-based installation. Docker is a new technology that has been gaining widespread adoption because essentially it bundles a lot of the software and components into a very easily installable package. And it also works on Mac, Linux, and Windows, in most cases at least. And so essentially, once the basic Docker engine's installed, all you have to do is clone our digital slide archive repository. This command actually pulls the Docker images from Docker Hub, and right now we're just essentially configuring it to kind of boot up on one of the many servers that we have set up. So in that case, I just showed you the whole DSA. So since this is slide management software, I want to just show you some very basic features. So in this case, you have the ability to pan and zoom, which is obviously critical. There's a thumbnail gallery on the left that allows you to essentially pick which slide you want to look at. And probably one of the most important features is it's not simply looking at images, but it's actually linking them to metadata. So in this case, I'm loading a PDF report. In this case, these are just essentially random collections of CSV or Excel files, which I'm essentially displaying as key value pairs. And all of this is essentially the front end. All of this is also stored on the back end. We also have the ability to load annotations that were generated using image scan scope. So now I'm going to briefly show you how we ingest data, i.e. how do we load data into the software. So one way to do it is, at least in our case, many of the files are already stored on the same server. Right now I'm just creating a collection or a project, we call them collections, where the images are going to be housed. Now what we're going to do is, this is generally an administrative feature, but I'm going to load the images in a second. Right now I'm just creating a folder underneath the collection where I plan on dumping all of the files into. In this case, I'm actually going to have two different folders, one showing a batch import, and the other case we can actually just drag and drop files. So an administrator would have the ability to essentially import data that is already on the same server. In the case of terabytes of data, you clearly want to do that. It's many, many times faster. So what I've done is I've pasted in a URL, which is a local, I'm sorry, not a URL, a file path, which is where the files are located on my system. I've selected what folder I want to dump everything into, and essentially I hit the import button. What the machine is doing now is it's going to the local file system. It's essentially walking or traversing the file system and indexing all of the files, and this works in real time. So I'm just migrating back to the folder that I just dumped everything in, and as you can see, these SVS files are now showing up. Thumbnails are being generated kind of on the fly. These are then cached. So the first time you take a little bit of a performance hit, but then those things are cached. And even though I'm currently in the process of kind of killing my file system, since I'm reading terabytes of data, the performance of the DSA platform itself actually isn't that bad. So another mechanism, particularly if you just have a couple of slides you want to upload, you can actually just drag and drop files. In this case, it's off the screen, but I dragged a file that was sitting on my desktop. I just dragged it onto that green area, and you can see the file progress. I'm jumping ahead because uploading a gigabit file over Wi-Fi takes a while. I'm just showing you, kind of for more technical-minded people, there's a whole API that allows us to programmatically interact with the system. The file was still uploading, so I scrolled back there. And fortunately, we're going to jump ahead a couple of seconds shortly, and now that file's actually showed up in the system. It's now indexed. So One of the things, since it's a management platform, you have the ability to rename and reorganize. So in this case, I'm just showing you, here's the actual file. But what we also have the ability to do is for each file or each slide or each object, you can actually go in and associate metadata or associate tags with each image. So you can see here, I'm just adding some arbitrary key value pairs. Also, depending on your study, you may want to have a more formal system of describing the stains, who generated them, what kind of animal, or what kind of where the sample came from, and the system is very flexible for that. In this case, I'm actually going to show you, I decided I want to reorganize some files, so I created a new folder. I'm going to randomly, well, in this case not randomly, I'm going to select a couple of files. I tell the system I want to either copy or move them. I then navigate to that folder, and then basically the files have now been copied there, but you can see there's also, essentially this is a shallow copy, so the files are now stored in two, or links to the files are now stored in two places. You'd also actually have the ability to move, so this again just depends on how you really want to organize things. And again, now we actually have the ability to add metadata to describe this entire folder. So you can describe both the slide, or you can also have metadata to the folder. Now, one of the more interesting things we've been working on is HistomicsTK, which is a system, or a toolkit essentially, that allows us to analyze these large images. So remember, a given image compressed can be multiple gigabytes, which makes it something you can't necessarily load into memory. So we also have the ability to actually spin up mini clusters. So in our case, we have 12 CPUs on our system. Our analytics engine can automatically take advantage of all of the cores on the system as long as we enable that option. I'm now going to give a quick tutorial, or really more of an overview of the HistomicsTK, and in this case I'm going to pick a file to run through our analysis. So I'm just selecting a file at random, just showing you sort of the basic interface. So once we selected a file, in this case I'm just going to run a small region of interest. That's obviously much quicker than running the entire slide. So I'm just going to zoom around. In this case, this is going to be a nuclear detection algorithm. So all of the parameters are visualized and can be customized, although in most cases the users are just going to want to go with the default. So in this example, we're just defining a small rectangle, dropping the coordinates in. We're now generating essentially an output file or results file, so telling the system where we want to dump it. We'll save that. And doing the same thing for the boundaries essentially. So there's sort of a description of nuclear size and shape, and then there's actually the boundaries. So these are two different files. Probably in later versions we'll just have these set to default. So in this case we've decided we like the options. We're going to hit submit. You can see here there's now a little spinning icon. This is actually the job that was just submitted to in this case, the kind of the local cluster. I'm going to switch tabs. You can actually monitor the status of the job. You can view all the parameters. You can see where it was sent, and as I'll show you in a second, I'll click on the job, and all of the provenance and all the metadata is actually stored. You can see that the job is still running, and we can also get some analytics on how long the various pieces take. So it has to communicate with the cluster, it has to copy the files over, and then it has to perform the computation. So most end users aren't necessarily going to be interested in all these details, but as you're trying to figure out why something's taking so long, having the ability to see how the data is being moved around the system will be very useful. So again, it's still running. This is another view where we can see the various tasks that have been previously run on the machine, and if you zoom in on some of the details, it tells you the type of job it was, how long it took, where it run. So as you can see, the results are now done. Again, we just ran a small region, so you see these little green dots, which correspond to the detected cells. We're going to zoom in further, and basically we now have the ability to going to see that results. Now that we see that it seems to have done a fairly reasonable job, we could then tell the system that, okay, these parameters look reasonable. We want you to run the thing on the entire slide. So I just want to, you can see some of our collaborators. I just wanted to thank anyone, and if you have any questions, feel free to email the team.